So we're going to start on section 10.7. We are skipping a section in the middle and we'll come back to it later. But we're going to start with ratio and root tests. Now the first one is ratio test, and this is the most versatile test and also the most important. This is especially useful when the series has expressions that involve exponents and or factorials. So first thing is, what are factorials? So a quick reminder. Factorial of n, which I'm sure you've seen before, is defined as n times n minus 1 times n minus 2 all the way down to 1. Furthermore, always remember that factorial of 0 is by definition 1. So first thing to notice is that this gives us a recursive relationship. So n factorial is n times, now so this is n, and the leftover tail is n minus 1 factorial, because it starts at n minus 1 and goes down to 1. So this is very useful. You could keep going down, so you could have n, and then this can be broken up as n minus 1 times n minus 2 factorial. So n minus 2 factorial is the remaining tail. So for example, if you have 8 factorial, that means 8 times 7 factorial. Or for that matter, 8 times 7 times 6 factorial. Okay, so now let's look at the ratio test. Again, remember, you do not have to memorize these tests. They are there in that table, and you will get used to them by looking at that table every now and then. So suppose the series AK is an infinite series, and what we do is we find R, which is the limit k going to infinity of this ratio. After we find R, then we check the value of R. So if R is less than 1, the series converges. Well, absolutely does not matter right now. It converges. It's called absolutely because if you notice, you are using absolute values here. If R is greater than 1, including infinity, then the series diverges. If R turns out to be 1, the test is inconclusive. That means you have to try some other test to decide whether the given series converges or diverges. The ratio test is not giving you any conclusive answer. Okay, so let's learn and practice with the following first classical example. So we want to see this series, which is 2 raised to the power n over n factorial. So does it converge or diverge? So let's start. So we have to find this R, which is limit n going to infinity a n plus 1 divided by a n. So that is what this is saying. So forget about the limit for a few minutes. Let's just find this ratio. Now the absolute value is not needed because this is all positive. So what is a n plus 1? So that would be 2n plus 1 over n plus 1 factorial. Then we divide it by a n. So that is 2 raised to the n over n factorial. So dividing a fraction by a fraction basically gives me, so once let me write all the small details. So you have this, and then you multiply by the reciprocal of the denominator. So that would be n factorial over 2 raised to the power n. Now after this we have to do some algebra, and very soon you'll get used to it, to clean it up and then take the limit. So let's try cleaning it up a little bit. Okay. So we get 2 times 2 raised to the power n, so that is this guy split up, divided by, then n plus 1 factorial can be written as n plus 1 times n factorial. This is the recursive relation that comes from here, times n factorial over 2 raised to the power n. And you will see the reason why we did this, because this cancels with this and n factorial cancels, and you are left with 2 over n plus 1. Now as n goes to infinity, so now you can take the limit. 2 over n plus 1 obviously goes to 0. Your denominator is going to infinity, so your limit is 0. And obviously this is less than 1, and by the very first result we can say that this series converges. Okay, let's go to the next one. So again, if you notice, we have a factorial, and because we have a factorial, we can safely try the ratio test. So an, it's always a good habit to first pick up an and write it, or ak. So this is n divided by 2n plus 1 factorial. Okay, so now we take limit n going to infinity an plus 1 over an. Again, let's hold on to this aside. Let's take the ratio, and this time I'm going to write n plus 1, because when I see n, I'm going to write n plus 1 divided by, now when I see 2n plus 1, since I have to find n plus 1, I'm going to write 2 times n plus 1 plus 1. Remember, I'm replacing n with n plus 1. So this is an plus 1. Now I have to divide this by an, which is obviously very simply n divided by 2n plus 1 factorial. A lot of writing. Okay, so now let's flip it. So I will get n plus 1 over, now 2 times n plus 1 gives me 2n plus 3. Do the algebra correctly. So 2n plus 3 factorial, and then the reciprocal gives me 2n plus 1 factorial divided by n. Okay, now let's do some algebra. So I'm going to have n plus 1 divided by, now 2n plus 3. Now remember, I have to cancel it with this guy. So I must bring it down all the way to 2n plus 1 factorial. So let's start. My first term would be 2n plus 3. The next term will be 1 less, which means 2n plus 2. And then I'll be left with 2n plus 1 factorial. Okay, the next is obviously the same as before, 2n plus 1 factorial over n. Now this and this term cancels, and I'm left with simple algebraic expression n plus 1 divided by 2n plus 3 times 2n plus 2 times n. So now we have to take the limit as n goes to infinity. So how do we figure this out? If you remember from your Calc 1, you would divide this numerator and denominator by something nice. Now, if you notice, the denominator has n to the power 3, because if you were to multiply this and the next term, you will get a cubic polynomial. So what I'm going to do is divide the denominator by n cube and the numerator by n cube. Okay, so let me repeat this. So what I'm doing here is dividing the numerator by n cube and denominator by n cube. So if I do that, what do we get? Now please follow this algebra. One approach is that you could obviously take these three terms, multiply them, and then divide by n cube. Or we could do it the way I'm going to show. So n plus 1 divided by n cube is obviously 1 over n squared plus 1 over n cube. In the denominator, you have n cube, so you have three n's here. So you can, one n will cancel with this n. So now you have n squared. So what we're going to do is give one n to this term and one n to this term. Okay, so what I just said is the following. You would have 2n plus 3 over n times 2n plus 2 over n. Okay, let's rewrite this. 1 over n squared plus 1 over n cube divided by, now let's divide these by n. So I would have 2 plus 3 over n, and the next term would be 2 plus 2 over n. Now we are ready to take n to infinity, because see, the idea is that n should be in the denominator, so it could be made 0. So what do we have here? In the numerator, I get a 0 plus 0. In the denominator, this term is going to be 0. This is going to go to 0. So I'm left with 2 times 2. So that means it's 0 over 4, which is 0, and that's less than 1. So my r is again less than 1. Therefore, the series again converges. Okay, let's go to another example. So this one is 2 raised to the power n over n raised to the power 20. So first, as usual, we should always make it a habit to pick out the an. So my an is 2 raised to the power n over n raised to the power 20. So now I have to take that ratio, and then at the end we'll take the limit. So let's take the ratio, and this time I will do the reciprocating at the same time. So I have 2 raised to the power n plus 1 divided by n plus 1 raised to the power 20, and then divide by an means I'll flip it to get n raised to the power 20 over 2 raised to the power n. Okay, algebra time. So first is easy. I have 2 times 2 raised to the power n. Then below this I'll write 2 raised to the power n. I'm just bringing this term below here, and then I'm left with n raised to the power 20 over n plus 1 raised to the power 20. So everybody can easily see that these two guys cancel, and I'm left with 2 times. Now notice that this term is raised to the power 20 and this term is raised to the power 20. So what I'm going to do is take them together. N over n plus 1 raised to the power 20. Okay, so I've just put them together. Now comes our division time. So what should I be dividing by? Well, as long as I do the same thing to the numerator and the denominator, it should be fine. So I'm going to take n divided by n and take n plus 1 and divided by n, and this whole thing obviously still has this exponent of 20. So this gives me 2 times 1 over 1 plus 1 over n raised to the power 20. And now I am ready to take the limit n going to infinity. So what happens? 2 stays 2 and this guy goes to 0. So I have 1 over 1 raised to the power 20, which is obviously 2. And now 2 is greater than 1. If you remember in the ratio test, if r is greater than 1, then the series diverges. So therefore, this series diverges. So please notice the kind of examples we did. We had exponents, we had factorials, and whenever you have these kind of exponents and factorials, ratio test is the most efficient way of testing the series. So we'll go on to the next one, but before we go to the next one, let's try our hand at one more. So here an is n cube over 2 raised to the power n. Therefore an plus 1 over an would be n plus 1 cube raised to over 2 raised to the power n plus 1, and then the denominator gets flipped and I get this. And by now you can see that you would have n plus 1 over n cube. So basically I'm taking this term and this term, putting it together, and then this and this leaves me with 1 over 2. So this is, now this time it's very easy. It's 1 plus 1 over n cube times half. So now if I take the limit n going to infinity, this guy is going to go to 0. So I'll have 1 cube times half, which is half, and that's less than 1. Therefore this series converges. Very efficient.